simplification of our mission. Our actual mission is to reinvent manufacturing so you can build anything you imagine.
Hi, everyone. Welcome to the 6th edition of the Shapr3D vlog. Today, we're going to talk about additive manufacturing, and we're super happy to have special guest with us, the CTO of Markforged, David Benhaim. David, thanks for joining us.
Thanks. Excited to be here.
It's a 40-year-old industry, but it seems like over the past 5 to 10 years, we've seen a much higher rate of adoption. And have we crossed the chasm with 3D printing and additive manufacturing?
Everyone has a pen and paper, but not everyone's an artist, right? And so even if everyone had access to free CAD, not everyone's a mechanical engineer. Yeah. And like when it comes to actually using a 3D printer, you kind of like for you and your custom applications, you kind of need to be able to design things to print on it, right? In the media, around the time that we launched, there were kind of 3 prevailing ideas of what 3D printing would be useful for, right? The first is like what I would say is the MakerBot dream, which is everybody has a 3D printer in their home, and Timmy prints toys, and John prints fixtures for his lawnmower to fix them, right? And you fix the dishwasher and all this other stuff, right? And I just explained that that's not really a reality because one, the printers are still expensive. They're kind of hard to use at the time. They're not perfectly reliable. And the design experience and the ability to make that custom part to print your lawnmower or even the, John Deere supply chain parts library doesn't exist, right? So you buy this box and you use it a couple of times as a hobbyist and it just sits there, right? The second is this idea that because additive can make things that no other process can make, you should do it with that, right? And the idea here is that you have, advanced genetic design algorithms, design these parts with fundamental laws of nature, and oh wow, they're making these things that look like bird bones. And the number of parts in the world that we're currently making today that have those requirements or even that you're going to replace are pretty limited, right? And so the classic example is that GE jet engine nozzle that they 3D print that is 17% more efficient or something like that, right? And that's a really cool idea. But the idea that you should be using this technology to make things that you can't make any other way is a falsehood, right? Because it's actually really good for a lot of other things. And then the third piece is this pipe dream of end use parts or mass manufacturing, right? That somehow 3D printing is going to enable this distributed manufacturing. And you have the Star Trek replicator, which can make anything as fast as you want. I didn't know that additive manufacturing was a 40-something-year-old technology. Think about what was software engineering like, what was mechanical engineering like, what was it like to get a PCB in the 80s? Or one of the things that we really do as a company, and this isn't, I think, super clear in our marketing, is that we're trying to make hardware a little bit like software in the sense that you can take those 1-year iteration cycles much, much faster. And we eat our own dog food with that. So the Mark 1 took us less than a year to bring to market.
Make sure you have a consistent wall thickness. Don't orient the hole in the wrong direction when you're printing it. And there are so many restrictions. Some survey I picked up showed that it was on the order of 40 to 50% of companies are afraid of deploying 3D printing because they need that specialist that guy in the corner to learn how different design strategies, which I thought was fascinating because I just want to design a model and push the button and see it come out the other side.
Again, in an ideal world, any physical system could be linearly decoupled, right? You have these individual modules with individual pieces, or even whatever they're doing, you could reason about them with separate vector spaces. That's not actually the case. Our 3D printer is not, it ends up being kind of nonlinear in function in the sense that you have multiple geometries present in a part, right? You can have a cylinder with some threads in the middle, printing the cylinder with and without the threads, or putting the threads on a different part, they end up commingling a little bit. They mess with each other. So actually designing a system that can process those perfectly every single time in presence of other geometry signals, not as easy as making it linearly separable. And ideally you make it linearly separable, but again, physics gets in the way. So our goal is to take this tribal knowledge and actually put it into the technology. And we've developed a number of techniques to do that. One of which is adaptive manufacturing, so making the machine self-aware. So on our X series machines, they have a laser, which actually can scan the parts in process. And this is always kind of about like Bridgeports and CNC is that you have a human in the loop, right? CNC, you're running code that the machine's automating running itself, but you're still checking the results of the machine. You're still setting it up, right? The machines are kind of dumb. They'll do whatever you tell them, even if you tell them to drive into themselves, right? There's things you could do in your design process to make the part more of a guarantee, but there's things that we do in the software to make them better. One of those things is like making the machine self-aware. So we have this ideal input, which is an STL. And the problem with an STL is it loses the notion of intent. So the software doesn't understand that you want this to be a threaded hole. It just sees a bunch of triangles, right? And that's good. So we're doing our best on one end to recover some notion of intent so that we can print that part to serve that function, right? The whole idea is you get a functional part out. It's not just looks like, feels like, it's does what you need it to do.
Sometimes, in order to 3D print a body, you have to split it into 2 or more pieces. In this month's tip, we'll show you a quick and easy way to do that using a double universal joint in Shapr3D. Select your body and tap Move, Rotate in the Transformations menu. Tap the copy badge to turn it on, and drag the body to duplicate it. Create a 2-dimensional quadrant using the rectangle and line arc tools under the sketch menu, with the x-axis splitting the bodies in half. Rotate the view, select 2 diagonal quadrants, and extrude them to cut both bodies in half. And there you have it. Your body is ready to be 3D printed. Thanks for tuning in to our Shapr3D Tip of the Month. If you're looking for more tips and tricks like this, check out our library of tutorials and webinar recordings, and make sure to subscribe to our channel for upcoming content.